Okay, so let's start taking a look at this stuff. This is going to be our last section for chapter 7. So it's building off of stuff that we've been doing in the past couple sections. So basically in the last section we were talking about when stuff is to like the powers, what we do, and then if it's a power of a fraction, what we do. Now what they're going to do is they're going to have it to a power of a fraction like that, but they're also going to make it negative. But we've learned what each of those individual things mean, so we're just basically combining it all together. So what you're going to do is you're going to take that little power of a negative fraction there and you're going to break it into its different parts. It doesn't matter what order you do these in. It's personal choice. Sometimes one way is easier than another way. It just kind of depends on the setup of numbers or whatever you're trying to find, the power of. I'm going to show you on the first example here. They make us do it out in 3 different ways, so you'll kind of see how that works. So remembering when we have something that's a power of a negative, what that specifically means is we take whatever our base is and we do the reciprocal of it. Do you guys remember what reciprocal is? Flipping it over, yeah. So like if we have something like this where it's the power of a negative, that part means we're taking whatever that value is, that x, and we're doing the reciprocal of it. So if it was just an x, it would switch to like 1 over x, okay? Or if it was like a half, it would switch to 2 over 1, okay? So that's what that part means. Then we remember from the last section, if it's something where it's like 1 over that power, we know that's the same as like the root. So like if it was to the power of 1/2, we know that's the same as like the square root of something. So that's what that is. So that 1 over n there, or whatever that fraction would be, the bottom half there, means we're taking that root of that, okay? So like square root, cubed root, that kind of thing. And then the last one there, whatever the top of that fraction is, that's just regular straight up powers. So if like the top of our fraction there was like a 3 or something, that would mean we take it to like the 3rd power. Okay, so like I said, you can do those in any order. Like you could start with taking your x to the power of m, then to do it to the -1, then to the fraction or whatever. It doesn't matter. Like I said, it's personal choice, and sometimes one way is easier than another, and you'll kind of see that when we start doing these examples here. And that's really all it is for notes. The rest is going to be examples. Okay. All right, so let's look at the first one here. So it wants us to evaluate if we've got, if we've got the fraction 27 over 1,000 to the power of -2/3, it wants us to figure out how we could rewrite this in 3 different ways to solve it, basically starting with a different power each time. Okay, so let's start with just rewriting this fraction out here. 27 over 1,000. And let's go with, on the first one, let's kind of do it in a setup kind of like this one, where we start with, if it's got a negative there, we can start by taking that fraction to the power of -1. Then my next one there, I'm going to just kind of follow that same setup there. So if this is -2/3, I've already pulled the negative out. So if I break that fraction up, I'm going to do the next one as like the power of a 1/3. Put it in parentheses again. And then the last on the outside there to the power of 2, because that's the top of that fraction. So then what I'm going to do here is I'm just going to kind of work this down and simplify, okay? So like we were talking about before, if this is a power of a -1, what does the power of negative do to our fraction here? Is that R word? Yeah, Braden's doing it. What's this? What's the word for this? Reciprocal, yep. So we're going to do the reciprocal, which is basically flipping that fraction over, right? So we just take the 1,000 and the 27 and flop them. So it would be like the 1,000 on the top then, 27 on the bottom. And that takes care of that power of -1, so that's gone now. So now we just got that fraction there to the 3rd, and then squared. Then we remember when we take something to the power of a 1/3 like that, that would be like the root of something. Does anyone know the cube root of 1,000? So what times itself 3 times is 1,000? Think about multiplying to get a bunch of zeros there. It is 10. So if I took 10 times 10, that's 100, times another 10, wouldn't that just add a 0 to the back? Should, right? So the cube root of 1,000 is 10. Anybody got cube root of 27? So what times what times what? gives us 27. It's got to be a small number. Or you can just do it on your calculator too. Cube root of 27, it is 3. So yeah, you can type those in your calculator too. So that part gets rid of that third part, because that's cubed roots. Then we just take that fraction, do it to the power of 2. So you just take your top number squared and your bottom number squared. So 10 squared should be 100. And then 3 squared should be 9. So that just ends as 100 over 9. Okay. Now with this problem, it wants us to do it in 3 different ways. So again, that's one way you can do it there. I'm just going to draw a line here and do another way. So they just want us to start with a different power first here. So instead of starting as a power of -1 for our first step, we can just start with something else. I'm going to start with a third as my first power. So I'm going to start 27 over 1,000 again. And again, most of the time you don't have to do this out 3 different times, but they're just asking us to here. So I'm going to go a third first. And I think I'm going to go squared second. And then the -1 last. Again, it doesn't matter. So this should be a little easier here because we've already done some of these things, right? So like if I'm looking to do cubed root of 27, what was cubed root of 27? 3. So I would switch to 3 over cubed root of 1,000. That was the 10. So then that third is gone. So now we just got to the power of 2, power of -1. Okay. So now, next step is we're just squaring something, right? And you always work inside out when we do these, just like you would in regular order of operations. Work inside your parentheses out. So anyways here, so if we're just squaring those things, well, that would just switch to the 9 and the 100 again, right? So that would just switch to 9, and then 10 squared would be 100. That takes care of our squared, so now we just got to the power of -1. Well, what's the power of -1 do? Switches it, or the reciprocal of it, right? So we just take that fraction and flip her over. 100 on the top, 9 on the bottom, and we get the same result. Yeah. And then the last one here, this is the one that I typically don't use because you end up with bigger numbers, and I'll kind of show you this here, but they want us now to start with the 2 as the first power. So if we're doing this one out, you'd have your 27 over 1,000 again. This time they want you to do it squared first, and then I'm just going to go a third, and then the -1, and again, they're just making us do this out in different ways. The reason I don't like doing this one here is because if I take 27 and square it and 1,000 and square it, aren't I going to get really big numbers? Yeah, which is kind of a pain, but again, they just want you to see that you can do it in any of these orders here and still get the same value. So if I do that, I don't know what either of those are off the top of my head. So 27 squared is 729, and then 1,000 squared, really it would just be adding 3 zeros there, right? So then that would be like 1,000,000. So then again, that takes care of the squared part. So then we've got the cubed root, and then that power of -1 there. And then you just cubed root those values. So like you would take that 1,000,000 to the power of 1 divided by 3, which gets us to 100. And then based on us doing the other ones, this should probably end up being 9, right? Just based on the ones we already did, but you could still do it there. 729 to the power of 1 divided by 3, which would be like the cube root of it. Which, like I said, it's going to get us to 9, and I just knew that because the previous ones are kind of following that pattern, right? So that gets rid of the third. Then we take her to the power of -1, which we know is just reciprocal, so flips it. Get back to that same 100 over 9 there. So like I said, I would use either one of these methods here, where I would either do the power of -1 first or the roots first, just because you deal with smaller numbers then. But like I said, it's personal choice, whatever you want to do. Okay, next one here. All right. So they want us to use this formula here. R is equal to 241 W's to the power of -1/4. Where W is our weight in kilograms to estimate a person's resting heart rate in beats per minute if the person weighs 240 pounds. Okay, well, what's a pain with this one is here our formula is in kilograms, but our weight is given in pounds. There's not a exact conversion there, but it's approximately 2.2 pounds is the same as 1 kilogram. You remember we did T crossbars before, or maybe you done this with Miss Brown? Remember the T crossbars for converting? That's how I like to convert stuff. kind of, you know, something like that. You don't have to convert it this way. You can figure it out other ways too, but I just like doing it this way because, I don't know, Miss Brown taught it to me and I remember it. But anyway, so what we do if we're going to use a method like this, to turn this 240 into kilograms, I'm going to take this 240 pounds and put it up here is what I'm starting with. It's kind of like a top of my fraction and bottom of my fraction. So my 240 pounds that goes there. And then my goal is to kick out an answer that's converted to kilograms. So then what I'm going to do here is I'm going to take this conversion rate here of 1 kilogram is approximately 2.2 pounds and put it kind of next to this here. Do you remember how I determine like what goes on top and what goes on bottom? They do have to cancel out. So what you want to think here is if I've got pounds as a label on the top here, I want my pounds label, the 2.2, to be on the bottom. And my conversion rate for that is that's equivalent to approximately 1 kilogram there. So I want that on the top. Because Creel's right, what happens here then is if you've got a label on the top and a label on the bottom, those just cancel you out. And aren't you left then with kilograms? Yeah, which is convenient for us, right? So then all you have to do is you just take all the stuff on the top and multiply it, and then all the stuff on the bottom and multiply it, and then you just divide at the end. So really here it's like 240 times 1, which is just 240, right? And then our bottom value there is 2.2 times nothing, so it's just 2.2 still there. And then you just divide those out. So like 240 divided by 2.2 would be like approximately 109 point, let's go 109.09 kilograms. So again, it's kind of a gross number there. And again, it was an approximate anyway, so it's not even, you know, super close anyways, but good enough for what we need it for. And like I said, you don't have to do it that T-crossbar way. That's just the way I always remember it from Miss Brown. But anyway, so now what we want to do is we want to take that value and we want to use it in that formula to figure out like what a person that weighs 240 pounds, what their true resting heartbeat should be approximately equal to. So our W here is like the weight. So really this value we just found there, that's kind of like our W. And we'll just put that into that formula. So it would be like R is equal to 241 times that W value we just found there. So the 109.09. And then we do that to the power of negative a fourth. So when you do this here, again, it's kind of up to you how you want to kind of go about it. If you want to start with the negative or if you want to start with that fourth root there. We would only have to do two things here because that top number is 1, so it's just negative 1 and then like a fourth root. So you could just go like 241, oops, that's not a 1, 241. Let's go with the negative first. So if I go like that value there and I go negative 1, and then I go like a fourth there, oops, fourth. If I take this and flip it, if it was just a regular number like this, what would the bottom of this originally be? Like if this was a fraction, what's the bottom of this fraction if it's just regular? Just a 1, right? So it's kind of like thinking of that over 1. So if we take and we flip that then, we'd have like 241 times 1 over that 109.09 to the power of a fourth. And then basically you're just cube rooting both of the, or not cube rooting, quad rooting or fourth rooting both of those numbers. Well, if we take the fourth root of 1, isn't just like 1 times 1 times 1 times whatever, that's always just going to be 1. So that top will still just be 1. And I'm not sure here, I don't think this bottom's going to come out nice, but we'll see. So it would be that decimal number there. I'm just going to, well, typically I would keep it on my calculator, but since I don't know if all of you guys still have it on your calculator, I'm just going to do it as 109.09. Typically I wouldn't round there, but I'm just going to keep that to the power of 1 divided by 4, which is a gross number again. Let's go 3.23-ish. And then basically we're just taking that top times that, so it would be like top times top, bottom times bottom, so like 241 over that 3.23. But realistically, if we're talking about like beats per minute, if I said 241 over 3, whatever, does that realistically make sense for a beats per minute? Not really. So then I'd probably divide there and I'd just go like 241 divided by that number. And it'd be like approximately like 74.6-ish. And then again, we're measuring that in beats per minute. There's kind of a lot of rounding in that, so like if you got something a little bit different there because we had to round a bunch of times, you know, that's, as long as you're close to that and you kind of show me your work out there, you'd be good on that. So like my answer sheet, I got like 75.3, but I think I rounded a little different or whatever, but as long as you're close to it, you should be all right. Okay, one more here. All right, we got Gary has 75,000 of the 200,000 he hopes to have in his retirement account in 8.5 years. What interest rate does Gary need to meet his savings goal? Okay, so they kind of give us this formula here. Very, very similar to the formulas we've been using before, where like it's going to kick out our total value here. The G is kind of like, the money that we're putting in there. You got that 1 for the 100%, R still our 8, and then the power of T. The only reason it's a negative here is because we're kind of trying to calculate this backwards. So like we don't have that money in the bank yet. We're kind of trying to go backwards with our money. So that's why that's that power of a negative there. But you would just use this if you're trying to do the savings stuff. So the G stands for whatever our savings goal is. So whatever we want to end up being. The S is how much money we have already saved. And then R, our annual yield or our percentage, and then again, T, time in years. Okay, so let's plug in our stuff that we've got here into this formula. So our savings amount that we already have saved up is that 75,000 there. So we'll go 75,000 is equal to, the G stands for our savings goal, so how much we want after that certain amount of time. So that would be that 200,000 number. And then we'll go parentheses, 1 plus, we don't know our interest rate here, right? That's what we're trying to find. So we'll just leave that as our R. To the power of, and then here again, because we're kind of working this backwards or going like back in time, it's a negative, but I would make sure we knew that if we needed that for a test or something like that. I'd make sure we knew that ahead of time. And then there they want it as 8.5 years. What we could do here, what they do on my little note sheet here, is they take 8.5 years and they turn that into a fraction. Any ideas what 8.5 years would be as a fraction? So it's like 8.5 right now. How do we turn that into, what do they call those, improper fractions? Do you remember how to do that? Not 9 over 2, because that'd be 4.5 is 9 over 2. So basically what you do is you take whatever this bottom number here is here times the front number. Okay, so like if we take 2 times 8, that would be 16, because if you had 8 holes that were split up into 2 pieces each, wouldn't that be 16 individual pieces? Yeah, so that would be like 16, and then so you multiply there, then what you do is you add that one there, so it would be the 16 from here plus 1, which would be 17. 17 over 2, yeah. Yeah. We should probably get that figured out before our Iowa assessments next week. Next week, I think. I'm pretty sure. Yeah, but you won't have your calculator for Iowa assessments. That's why we gotta know how to do it out. Okay. Worst case scenario, it's multiple choice. You can guess and check and see if they gave you a calculator, divide them out and see which one's all whatever. But we should know how to do that. That's something we should just know off the top of our heads. Anyways, so that'd be the same as like negative 17 over 2. So then here, if my goal is to solve for the R, again, when we do this, we want to think, when we're solving, we want to work order of operations backwards. So we want to start with add, subtract if we can. Here, this add, subtract is in parentheses, and parentheses is always our last thing, so we're not going to do that. So we don't have any other add, subtract, so then we go multiply, divide. So we would want to get rid of this multiplying first here, dividing by 200,000 on each side. And when you divide that out, it should come out nice. Comes out to 0.375, or like all those zeros would cancel out there and it'd just be like 75 over 200, if you want to think of that as well. Or it's the same as 3/8. Maybe let's make it 3/8. And I just know that because you can pull 25 out of each of those and get it down to 3/8. That might be easier for our fraction stuff here. It's equal to, okay, so all that stuff's gone. So we just have 1 plus R to the power of that negative 17 over 2. Now what happens, like what do we have to do to each side here to make this power go from this side to this side? Like what do we have to do? Remember? And not multiply, it's to the power of the reciprocal, but it looks kind of like it's multiplied. So what we're going to do here is we're going to go like this, and then we're going to do it to the power of the reciprocal of this. So we're going to flip this to negative 2 over 17. And then you do that power of negative 2 over 17 to each side, right? Because then we know powers of powers, what you do is you multiply. Well, wouldn't all that stuff cancel out there with powers of powers, and we're just left with 1 plus r? And then over here, what I would be thinking, well, if I've got to the power of a negative, what's that going to do? Flip that fraction. So if this is just to the power of, so if I think of it as like, I'm just going to write off to the side here, negative 2 over 17, or 3 over 8. If I break this to its different parts here, if I go like the power of a negative, I'm going to go squared and then the root of 17, because I don't think that root of 17 is probably going to come out nice, so we'll do that as the last step. So like we said here, if we do the power of a negative, that's going to take that fraction and flip it. So it'll become 8 over 3. Then we'll have to the power of 2, the power of 1 over 17, or the 17th root. And then here, squaring would be a little bit easier to do first, because we know what 8 squared is, and we know what 3 squared is. So 8 squared would be 64. 3 squared would be 9. Then we could do that to the power of 1 over 17, and then this is where I think it's probably going to turn into gross stuff. So let's just do it all as 1 to the power of 1 over 17 here. So let's just go parentheses, 64 divided by 9, parentheses, to the power of 1 divided by 17. If this came out to be a better number, I would just do that right away, but it's not going to. So I just kind of type it like that. Hit enter there, and then like I said, it's not going to be a very nice number just because 17th root of something's not pretty. So we'll just go that it's about 1 point, let's go 122. And then our last step there, if we need to get that r by itself, we would just have to get rid of that plus 1 by subtracting 1 from each side. So gone, so then we'd have like 0.122 is equal to our r. Now, if this is as a decimal and we need to turn it to a percentage, how do we take a decimal and turn it to a percent? Times it by 100, right? So it's like we're timesing that by 100 there, or just moving our decimal over 2 places. So that would end up being that our r is approximately equal to 12.2%, which would be a pretty darn good interest rate if you could get in on that. That'd be a pretty good deal, is 12%. Or even like 5% would be pretty good. Okay, so that's that. Some of them are harder than others, you know what I mean? A lot of them, they're going to mix in like variables and stuff, and then, you know, variables you can't, you know, necessarily just revert to using your calculator on stuff like that. But yeah, so that's, like I said, our last section. So we'll do this assignment for today. Tomorrow then will be worksheet day like normal. Wednesday will be quiz, and then we'll be coming up on the test. Probably, I don't think we have school next Monday, so probably like next Tuesday. Probably where we're at on the test. So.